Hello everyone, thank you for still being with me. So what I'm going to be doing in this video is walking through an example problem where we're going to try to find a cost function on the basis of a firm's production of technology and the cost of inputs, right? The cost of labor and the cost of capital. So just to make sure we're on the same page, this video is 100% optional. You don't have to watch this video, but it's here in case you find it helpful to see some additional examples. And do whatever you want with this video, right? It might be helpful for you to try to work this out yourself first, and then watch the video, pause to try to do each step yourself, and then see what I do, whatever it is that makes this useful for you. Okay, so our goal, right, is to find a cost function. So the first thing I want to do is just make sure that we understand what it is that means, right? What it is we're aiming for, so we can think through what we have to do to get there. So what is our cost function? Well, a cost function is going to be, right, some C of Q. It's going to tell you the amount of money it costs to produce Q units of output. And this is just going to be the cost of all the inputs that you use to produce Q units of output. Right, so this is going to be W times L of Q plus R times K of Q. Right, makes sense? And importantly, L of Q and K of Q are the combo of L and K that produce Q as cheaply as possible. Right? So we already know W, we already know R. Our goal is to find these two last objects, right? L of Q and K of Q. So I'm going to make these blue to show that we need them. Okay. So how am I going to go about finding optimal L of Q and K of Q? Well, what I'm going to do, right, is I'm going to solve the plant manager's problem, right? Essentially what we're going to do here is say, we need to find our cost minimizing combination of L and Q that would allow us to, L and K that would allow us to produce at least Q units of output, right? In other words, we have a picture, something like the following, right? We're going to have some isoquant of the combinations of F and LK that produce Q units of output, and we're going to want to find the combination of L and K that does so as cheaply as possible. Right? This makes sense? Isocost, which is going to have a slope of W over R. Cool. Okay. So where are we going to start with our cost minimization problem? Where I would like to start is by finding our MRTS, right? Trying to understand our production of technology a little bit better. So let's first find our find our MRTS. So we can say our MRTS, in terms of L and K, it's going to be dFdL over dFdK. Right? How much capital does it take to replace a worker? That's going to be the productivity of labor over the productivity of capital, right? The more productive workers are, the more capital it's going to take to replace a worker. The more productive capital is, the less capital it's going to take to replace a worker. Right? Why does it make sense that we want to know the amount of capital it will take to replace a worker? Because we're trying to get the slope of our isoquant, right, which is going to be the, change in capital over the change in L, right? Rise over run. Cool. Okay. So what's dFdL? dFdL is going to be 4 times 1/2 L to the 1/2 minus 1, right, times K to the 1/4. And dFdK is going to be 4 times L to the 1/2, right, treating L just as a number, times 1/4 K to the 1/4. Right? This makes sense? From here, we can say, K to the 1/4 minus 1. Right? So what do we do from here? Well, we say that K to the 1/4 divided by K to the 1/4 cancels out. L to the 1/2 divided by L to the 1/2 cancels out. 4 and 4 cancels out. Right? So what we're left with is an MRTS that's going to be 1/2 over 1/4 times L to the minus 1 over K to the minus 1, so that's K over L. Right? 1/2 over 1/4 is 2, so 2 times K over L. This makes sense? Let's do a gut check to make sure that this answer works. What they're saying is that the more capital we have, the more capital we'll need to replace labor, right? the more workers we have, the less capital we'll need to replace each worker. This makes sense, right? Because essentially this suggests that capital and labor work together effectively, right? More workers make capital more productive, more capital makes labor more productive. We have a tube here, right? Which means that if we had the same amount of capital and labor, we need 2 machines to replace a worker. That's going to make sense because if we look at our production technology, we can see that L has a higher weight than K. Okay, beautiful. So now that we have our MRTS, what should we do with it? Well, the first thing we might want to do is to think about what kind of solution we're likely to find, right? Are we going to find an interior solution? Is it possible that we'll find a corner solution? So what this is going to tell us is that there's no way that we'll find a corner solution, right? It tells us that we'll have an isoquant that looks something like this. How do we know that? Because if we had no capital, right, our MRTS would be 0, which means that we would be right, unable to produce anything, right, by adding labor and removing capital. If we had no labor, our MRTS would be infinity. Another way to see this is that if we had no labor or no capital, we wouldn't produce anything, right? Our production would be 0. Great, so we've got to have an interior solution. So what do we need for an interior solution? We need 2 things, right? The first thing we need is that our MRTS has to equal our price ratio, W over R, right? Why is this? Why does this make sense? Because what this is telling us is that our MRTS is tangent to our ISO cost curve, right? There's nothing that's going to be cheaper and still produce enough output. It also makes intuitive sense that the amount of capital it takes to replace a worker should have to equal the amount of capital you could buy for a worker's wages. Beautiful. So that's the first thing we need. The second thing we're going to need is we're going to need to plug this into our isoquant. Right, so we're going to need that F of L and K equals Q. Right, we need to have enough labor and capital to produce Q units of output. Okay, great. So let's start here. So we know that 2 K over L has to equal W over R, which is 20 over 80. Right? We can solve for one in terms of the other, so we can say that K has to equal 20 over 2 times 80 times L. So K is going to equal 1/8 of L. Make sense? And again, right, this is a reasonable answer because we know that labor is a little bit more important than capital. We also know that capital is more expensive than labor, right? So we should be getting that we're going to have less capital than labor. Great. What do we do from this? Well, we plug it into our isoquant, right? So our isoquant is going to be 4L to the 1/2 times K to the 1/4 equals Q, right? But I know that K is 1/8 L. So I'll say 4 times L to the 1/2 times 1/8 L to the 1/4 equals Q, right? From here, I just have an algebra problem where my goal is to find L as a function of Q. Now, the only problem is I've got these powers, so I'm going to have to do a little distribution, right? I'll say 4 times L to the 1/2 times 1/8 to the 1/4, which I'll just leave alone for now because this is going to be ugly and horrible, right? Times L to the 1/4 equals Q. Mush together the 2 L, so I'll say 4 times 1/8 to the 1/4 times L to the 3/4 equals Q. Get L by itself, right? So I'll say L to the 3/4 equals Q over 4 times 1/8 to the 1/4, right? This is going to tell me that L has to equal this whole thing to the 4/3, right? So Q to the 4/3 divided by 4 to the 4/3 times 1/8 to the 1/4 to the 4/3, right? Which is going to be 1/8 to the 1/3. Make sense? So this is going to tell me, right, 1/8 to the 1/3 is 1/2. So L is going to equal Q to the 4/3, Q over 4 to the 4/3 times 1/2. Good? And then what's K going to be? Well, K is 1/8 of L, right? K is going to be, oh, I'm sorry, this isn't 1/2, this is 2, right? Because 1/8 to the 1/3 is 1/2, and then we bring it to the top. So we'll say 2 times Q over 4 to the 4/3 is L. K is going to be 1/8 L. So K is going to be 1/8 of this, which is going to be 1/4 times Q over 4 to the 4/3. Great. Okay, this makes sense? So what we've just done, right, what we've just solved mathematically is our optimal choice of L and our optimal choice of K for any given quantity Q, right? And essentially what we're saying is that we're going to use more labor than capital to produce Q. The amount of labor and capital we're going to use is going to go up as Q goes up. This makes sense. We also can see that when Q goes, let's say Q doubles, L is going to more than double, K is going to more than double, right? Because we've got Q to the 4/3, which is a power above 1. This makes some sense because if we look at the coefficients here, right, if we doubled L and K, we wouldn't quite double output. Okay, great. So what do I do from this, right? This is very close to my answer, but I haven't quite gotten to what I'm looking for. What I'm looking for, right, is the cost of producing Q units of output. So all that's left is to take these two expressions here, L is a function of Q and K is a function of Q, and plug them back into our cost function. Right? So the last thing we'll do is we'll say that our C of Q equals W, which is 20, times L of Q, which is 2 times Q over 4, the 4/3, plus 80, which is R, times our K of Q, which is 1/4, times Q over 4 to the 4/3, right? 20 times 2 is 40, 80 over 4 is 20, right? So 40 plus 20 times Q over 4 to the 4/3, right? So our C of Q is going to be 60 times Q over 4 to the 4/3. Beautiful. Okay, and there we go, right? This is going to be our cost function. What's this cost function telling us? It's telling us that, right, the cost of producing Q units of output is going to be higher the more output we're trying to produce, right? If we put in some numbers to make sense of this, like let's say that I put in a Q of 4, right, in order to produce 4 units of output, it would cost me $60, right? What if I doubled that? I wanted to produce a Q of 8, right? Then I would have 60 times 2 to the 4/3, which would be more than double 60, right? It would be more than 120. This make sense? Great. Okay, so that's that. Hope this was helpful. Looking forward to seeing you all soon and talking to you in real life. I'll move over here for a minute so that you can pause the video and look at the whole thing. Great. Okay. Have a good one.